All right, people, we ready for this? We're going to make this quick. We only got so much time, and I need to get to the rest of these slides. So, name a quadrilateral that has that has congruent diagonals. Let's see here. Hang on, where are we at? I want to draw. Let's go you. All right, that has congruent diagonals. So, think about this. If you drew it out, let's say that's a diagonal. Let's do a little crisscross. That's another diagonal. A little bowed out there. But if you connect them, think about what shape it's going to make. And that is definitely the rectangle. Okay. Name a quadrilateral. Oh, I guess it could go a little bit further. Congruent diagonals. Rectangle is the first parallelogram that has congruent diagonals. But the second one will be the square. Okay. All right. Name a quadrilateral that has only two congruent sides. And when I saw this, I had to do like a double take. Because if you only have two congruent sides, that really doesn't mean a whole lot for you. Normally you hear that with two sets of congruent sides or one set of congruent sides. So we're going to say nothing exists, doesn't exist. Okay, not up here. Wait for a few more details. Name a quadrilateral that has 0 pairs of parallel sides. So think about it, you can't even have a parallel side. So this makes me think of the famous kite, because these opposite sides will not be parallel, nor will those. Okay, so definitely the kite fits this bill. And let's see here, there's another shape which we don't really learn about. I'm gonna throw it on here. This is for free, and it's like when you concave on a quadrilateral, you get what they call a dart. But I won't tell you right now, that's not on test, that's just free. Okay, yeah, go for the kite on that one. Rectangle, and then yeah, all right. So name a quadrilateral that has 4 right angles. All right, so the first parallelogram that picks up right angles by definition is going to be the rectangle. Again, it's the first shape where you see right angles. And you're going to have 4 of those. Of course, and then what else will have it? And then say the square. Because the square will basically have all of these traits. All right, name a quadrilateral that has perpendicular diagonals. So think about it. Let's say you had a square that got pushed on its side, where all the sides were the same length. Boom, 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 boom. This is the rhombus. And definitely, if you look at the when you look at the diagonals, they will definitely be perpendicular. They'll be right angles. And for that matter, guess who else? The square. Like I said, the square fits all these. If I had room here, I'd draw the family tree. With the time, maybe I'll do that on a different video. But definitely the family tree is worth seeing. Let's move on to the next one. Here we go. So we can use slope to prove different properties of parallelograms. So if you want to show the sides of the parallel, that means you want to show that they have the same slope. Okay, same slope means same direction. Same direction. So same direction, same slope, parallel. If you're going perpendicular, you got to go radically different here with the slopes. So not just opposites, you want to go opposite reciprocals. So opposite reciprocal. Okay. So if you want to say diagonals are perpendicular, guess what you're going with? Opposite recips. Okay, just like you did up here. Opposite reciprocals. Anytime you want to show that they are perpendicular. So how can we find the slope given 2 points? You can always go with the formula. A lot of people like to go with that. So you go y2 minus y1, because remember, slope's always on top. x2 minus x1. How can we find the slope if we're given a graph? Hey, use the slope triangle. So, sorry about that, slope triangle. Okay, so like basically if you got a point here and a point here, you want to go definitely straight up. You want to go straight across, connect them with a very right triangle. But that's what we mean by that, because you're going to get the rise and you're going to get the run. Okay, so again, slope triangle, we wanted to connect your 2 points with the triangle, so rise, run, and you just write it out. Okay, and that's how you find the slope. All right, let's move it on. Gotta get to some details here. Okay, so prove that a quadrilateral ABCD is a parallelogram by showing the opposite sides are in fact parallel. So the faster you get on this, the better off it's going to be. Change the color up here. All right, here we go. I'm just going to start up here with the top. Let's do BC. Since we're on the graph, I'm going to visual here. I'm going to go with the slope triangle. So I'm going to go straight up. I'm going to go straight across. I'm going to make that right triangle. So let's get the rise and run here. So you're going to go up 2. That's a positive 2. So think about direction. Anytime you go up, it's positive. Anytime you go to the right, it's positive. So we're going to go up 2, right 3. So both these numbers are positive. So when you write the slope, make sure you always put rise over run. So the vertical is your rise and the horizontal is your run. So the slope of this line is 2/3 and it does not reduce. Now let's go and do the opposite side here. So here we go. Let's go straight across and let's go straight vertical. So let's see here. If you're going to the right, that's +3. If you're going up, that's a +2. So let's write the slope. So slope is equal to, now again, make sure you put the rise on top. The rise was the 2, +2. The run was the +3. And again, that slope's 2/3. So you got one set of parallel sides right there, and you go ahead and put your arrow on those sides. All right, let's change up the color. Oops. Let's go with, yeah, let's go navy. All right, let's go over here. So from A to B, let's go up, and then we're going to go over 1. Okay, so we're going to go up. That's a +3. We're going to go to the right, +1. So if we write that slope, again, rise goes on top. So you put the 3, you went up 3. And now you're going to do the run, which you went over to the right 1. So you can say that's 3 over 1 or just 3. All right, over here, let's do D and C. So just connect those to a right with a right triangle. All right, so from D to the right here, I'm going to go right 1, and then I'm going to go up 3. Both those are positive directions. So slope is going to be rise 3 over run 1. So again, notice opposite sides are the same. It's the same slope, which means they are, in fact, parallel to. I'm going to use 2 arrows. Okay, so I have 2 sets of parallel sides. And let's see here, coming back over here, slope of AB was what? AB was 3 over 1. Slope of BC was 2/3. Slope of CD was 3 over 1. And slope of AD or DA was 2/3. And again, of course, those are the same, and then those are the same. So you have 2 sets of parallel sides, which means therefore, and this is a symbol for therefore you have a parallelogram. Okay? All right, moving on. Next slide. 922. Okay. Prove the quadrilateral ABCD is a rectangle by showing there are 4 right angles. All right, now listen, if you're going to show there's a right angle, think about this. Right angle means these sides have to be perpendicular. Perpendicular, good spelling. Perpendicular sides. You got to have perpendicular sides in order to be a right angle. So therefore, again, remember what needs to happen. that means you need, oh, that's awful. Terrible spelling. Go back. You gotta have opposite reciprocal slopes. And again, roll up the sleeves and get in here as fast as you can. Bad news on this one is we don't have the points already out here, so I'm going to put them on here real fast. So we got -5, +1, so you're going to be right there. Go ahead and label these -5, 1. You got -2, +4, so you're going to be up here. The next one is 4, -2. And then you got 1, -5. So we're way down here. All right, so I'm going to try to connect these best we can. Wish I had a straight edge for this kind of thing. And then coming straight down through here. Now, if you know what you're looking for, you can probably look at this and say, yeah, they look like they're going to be perpendicular, but we're going to go ahead and prove this. All right, I want to show this by the slopes. Now, you got options. You can go visual with the slope triangles, which would probably be pretty fast. Or since they got the points formula here, let's just get the hint and go with the slope formula. So here we go, slope AB. So hang on, who's that? A was over here, B was up here. That's a terrible color. So AB, so we're going to just go straight to the formula. So we're going to go Y2, which is going to be that second Y up there, which is what, 4? 4 minus the first Y1 divided by, let's go back to that same point for the X, -2 minus -5. And watch your double signs in here. So 4 minus 1 is a 3 on top. That's going to be a plus. So -2 plus 5 is going to be 3, in which case you just get a +1. All right, I'll go with that. All right, let's see here. C is going to be down here, 4, -2. So let's throw that in the formula. So slope is going to equal 2. We'll start off with that -2 down there with C. That's that Y. So -2 minus the first Y. Go back to see where you started from. So 4 minus the first X. So here we go. -2 minus 4 more will take you up to -6, down to -6. Double sign again, so that's a plus. So 4 plus 2 is 6. And now you're looking at a -1. Okay, slope CD. So now we're coming down from C to D. Here we go again. Slope is going to equal 2. Let's go with that. Second Y minus the first Y over the second X minus the first X. So double sign. So -5 plus 2 is going to be -3 over -3, which gives you a very +1. A lot of ones. All right, let's do D and A. So we're right here. So slope is equal to, let's go with that, 1 minus the -5. Now we're going to do the x's, start with the same point. So we're going to start with -5 minus the 1. All right, so double sign. So that's going to be a plus. So 1 plus 5 is going to be 6. -5 minus 1 is going to be -6. And that definitely gives you -1. So now, since we're going for perpendicular, we got to make sure we're thinking about opposite reciprocal. So if you do get a whole number, you can always stick it over 1. So that's 1 over 1. This is going to be -1 over 1. +1 over 1, -1 over 1. So opposite reciprocal slopes means you're definitely going to flip a fraction. So here they're both 1s. That doesn't really matter. But definitely you got to change the sign with the opposite. So let's change color up. So definitely these two are going to be opposite reciprocals, as well as these two. And if you go back over here, we'll just detail it out. The slope of this one was 1. Slope of this one was -1. Slope of this one was the +1. Slope of this one was -1. So if you look at this, Between 1 and -1, those are opposite reciprocals, so that's a right angle. Between 1 and this -1, those are